5.6 rational functions. Let's start by doing the domain. So the reason we start by doing domain is what you're going to find is that you've really already been working with rational functions in quite detail. You just didn't know it yet. So remember that fractions have restrictions, right? So remember we set the denominator equal to denominator equal to 0, and we solve for x. That is going to be the number that the domain is going to skip. That'll be important later because what you're going to find is that this is actually the vertical asymptote. So if we do that with the other one, we need to factor it. So that'll be, let's see, x minus 3, x plus 1. And so we'll have 3 and -1 both get skipped. So there's going to be quite a few unions here, which is okay. Remember, everything is going to be in parentheses. So there's your domain. Now, some things to note about the reciprocal function. We've already kind of talked about it back in chapter 3, but we're introducing something new called end behavior with directions. This doesn't come up as much in our class as it does in calculus, so I introduce it because I want you to have seen it before, but we won't be too focused on it in our class. The plus sign means we are coming from the right side. Okay, so the way that I would say this is as x approaches 0 from the right, which means the minus is from the left. Everything else should look pretty familiar because you've done that before, like you've seen it in chapter 3. Here is the table that shows some of that notation. Again, the only two things that are going to be new are the directional end behavior for minus and plus. Vertical asymptotes are going to be one of the focal points for today. So let's go ahead and talk about what those are. They are vertical lines that we approach but do not touch. We never ever touch them. There are no exceptions to this rule. And you've actually been finding them for many, many weeks now because what we did in the warm-up is how you find your vertical asymptote. You are setting the denominator equal to 0 and solving for x. Right? We talked about how the denominator can't be 0. And what happens when it is 0 is the vertical asymptote. Since it is a vertical line, it has the equation of x equals c, where c is a constant number. So just keep that in mind. It's always just going to be x equals. It's just going to be a vertical line where x equals c. That being said, now we can just write the vertical asymptotes as an equation. Similar to what we were doing with domain, we're using that same number, but now we're setting it equal to x. So here, your vertical asymptote would be x equals -2. Here we have to factor, and there's going to be 2 vertical asymptotes, which is fine. I'm thinking -5 and +1. So we have x equals 5 and x equals -1 for your vertical asymptotes. Here, this one's already kind of factored for you. So we have x equals -1 and x equals 4. And so those are all your vertical asymptotes. Horizontal asymptotes are very similar. They're just horizontal lines that we approach, but do not touch most of the time. And I'll go ahead and write most of the time here. There are scenarios where they will cross. So if your horizontal asymptote is at y equals 0 and you have an x-intercept, then it will cross the axis, which is the asymptote. And we'll do an example of that and you'll see how that happens. Now there's three ways to find a horizontal asymptote. It really depends on the scenario you're working with, and there's three scenarios. The third one is going to be in pre-cal. So I will show you what it looks like. We won't do any examples of it. You'll just know that it exists. Okay. So case one is going to be if the degrees, I should say the highest degrees of the numerator and the denominator match. So notice these are both a power of 1, which means they match. So what you can do is you can take those and simplify their coefficients, right? There's technically ones in front of them. So this is going to have a horizontal asymptote at y equals 1, right? Thinking about it, right? Horizontal means it's a dashed line left to right, which means it's going to be y equals c, where c is some constant. So that's why we're setting it equal to y. Okay. Now, if it was, let's just say 2x over x minus 4, the same thing's going to happen, right? Those powers still match. This is just going to be 2x over x, which would equal 2. Okay. So you're just simplifying those coefficients. The constants, whatever they might be, don't matter anymore. Okay. So that's the first case. The second case, let's switch to a different color, is when you have a smaller power in the numerator than the denominator. So this doesn't have a power. This is a power of 0. And this is a power of 2. Okay. If the numerator's highest power is smaller than the denominator's highest power, then it's just 0. There is no math required. Okay. There is no math required. So it says here the numerator is smaller than the denominator. Okay. The power, the degree, the power, whatever you want to call it. So those are the two cases we are going to be working with. The third one, like I said, is going to come up in pre-cal, but that is when you have the opposite of case 2. The numerator is greater. So this is a power of 3. This is a power of 2. So what actually ends up happening is that you have a slanted asymptote instead of horizontal. So instead of it looking like a horizontal line, it's a slanted line, like a literal line, like a line that isn't just vertical or horizontal. Okay. I won't show you any of the details of it because you don't need to worry about it, but just know that that will come up in pre-cal. Well, now we have to put everything together. So we have to find x-intercepts, the y-intercept, and the equations of the vertical and horizontal asymptotes, which we can now do. Okay. We've now talked about how the denominator can help us find our vertical asymptote. So we know that's going to be -2. We also know that we can look at the very front of our fraction and determine our horizontal asymptote. So that's 2x over x. Sorry, I wrote a 2, which means we're going to have y equals 2. Now, the other two I have not explicitly shown you how to do, but I think theoretically you could do it, right? So you know that the coordinate for the y value on the x-intercept is 0, and you know that the x value for the y-intercept is 0. So you can plug those in respectively and solve. Actually, I'm going to do those in different colors. Let's do that in purple. Okay. So in purple, I'll go ahead and solve for my x-intercept, right? This is technically y. So I have 0 equals 2x minus 1 over x. I think that was a +2. And now I don't remember because I'm covering it. Yeah, it was a +2. +2. I need to get rid of my denominator. Okay. Everything over here equals 0. So I'm going to bring that 1 over, and then I get 1/2. All right. So that means my x-intercept is 1/2. Another way to think about this is that you are just solving the numerator. Okay, you are solving the numerator. I like to box things and color code them. So if that is helpful to you, feel free to do the same. But if it's not helpful, don't feel obligated to do that. So let me shrink that so we have more room. And then let's do the y-intercept. Now that's when x is equal to 0. So we have y equals 2 times 0 minus 1 and 0 plus 2. So we're going to be left with negative a half. Another way to think about this is you're really just looking at the constants at the end, right? They're right there. They're in front of you. It's negative 1/2. Similar to polynomials, similar to quadratics. It's always the constant at the end. In this case, it's a fraction, and that's okay. So now we have everything we need to graph this. I'm going to switch back to my blue and I'll color code my graph. So my horizontal asymptote will be at 2. So I'll just go ahead and make this line equal to y equals 2. And then we'll do the same thing for our vertical asymptote at -2. Label that as x equals -2. And now we'll just plot those points that we have. So we know that 1/2 will be approximately here for the x-intercept. Negative a half will be roughly here for the y-intercept. So this is honestly enough because if you look back to our curve, we know what it roughly should look like. It should have that curvature on opposite sides. So if I know, let me come back here. If I know that this bottom right corner has 2 points, I know that I should have a curve over there. Otherwise, that wouldn't really make sense. So I'm going to go ahead and draw my curve there. Okay. I also know based on that figure from earlier that if my curve is on the bottom right, the other curve is on the top left. That's all you need. I do not need you to find any other points as long as you know what that shape is going to look like. Now, obviously, it's not always going to be this easy. Sometimes you're going to have to plug in points. Sometimes you have more than one vertical asymptote. We'll do some of those examples, but this is the general idea. Find these 4 things and you have a pretty good starting point. Let's look at this next one. We'll go through those steps again. So denominator is going to be my vertical asymptotes. So let's factor. I'm thinking x minus 5x plus 1. So that's going to be 5 and -1 for my asymptotes. All right. And then look, this doesn't have a power on top, but it does have a power on bottom. So we just have 0. Okay. My y-intercept, if you look at that, is just going to be -2/5. Okay. My x-intercept doesn't exist. There is no x-intercept. Okay. Because there's no x to solve for. We can't set this equal to 0 because that doesn't exist, right? So there's no x-intercept, and that's okay. That can happen. That's allowed. From there, let's go ahead and graph everything again. So I have my horizontal asymptote at 0. I mentioned that that can happen, and that's okay. And then I have my asymptotes that are vertical. Let's do that roughly. Again, I'm just kind of putting them wherever I want. So -1 and 5. I recognize they're not necessarily very drawn to scale, but I'm not too worried about it, to be honest. Y-intercept of -2/5. Okay, so here's the thing. I don't have x-intercepts, which means I cannot cross this line. I can't, right? There's no way to do that because I found that there's no x-intercepts. So that means this cannot cross here or it cannot cross here. That means the only option is for this curve to go down like this, right? It can't go up, it can't curve, it can't do any of those things. It has to Let me find a color to use. It has to come up, touch this, and then curve back down. That is my only option. Now we run into the issue of what is happening over here and what is happening over here. Because we do have more curve. There should be more. It's not just this. So this is one of those scenarios where you might have to plug in some points. So something you can do is think about this like you did the polynomial inequality. You had your critical points and you tried different numbers in each category. Those critical points were asymptotes essentially, because that's where the function was zero or that's where the function couldn't exist. So I'm just going to pick a number somewhere on this side that's smaller than -1. So let's say if x equals -2. Whoops, let me scroll. Maybe, maybe not. So 2 over -2 squared minus 4x, 4 times -2 minus 5. I really don't care what the number is. I just want to know if it's positive or negative, right? Because this is positive and this is negative. That's all I care about. If I figure out if it's positive or negative, I know where the curve is. That's all I really care about. So that 2 is positive. This will be +4, +8, -5. That's also positive. So that tells me, oops, that my curve is going to be up here. I know that that's the shape because these are functions and they continue forever and they're going to continue to approach those dashed lines but never touch them. Okay. From there, I can do the same thing for the other side. Let me make this a little bit smaller so we have more room. Nope. And just make it right there. So let's do if x is 6. So if x is 6, we have 2 over 6 squared minus 4 times 6 minus 5. So that's again a positive. We have a positive 36 minus 24 minus 5. I believe that's also positive. So that means this curve is also above the axis. Now you're done. Again, I don't necessarily need the exact point of this. I really don't necessarily care what it is. I just want to know if it's above the axis or below the axis because I don't have anything else to work off of, right? And yes, you might have a graphing calculator, but here's the thing. I don't necessarily care about the graph. I care about, can you figure out a way to understand how to find what this graph looks like critically, right? Yes, you can plug it into a calculator. I care more about, can you work your way through a problem where you don't just have everything given to you, right? So that's kind of what you would want to do. You have to approach it from that context. Just plug in some stuff, see what happens. You don't need more than this, right? You don't need any other points. Let's do this last one. So for the x-intercept, we'll go ahead and set this equal to 0 and solve. So we'll have 3, 0. For our denominator, we can find our vertical asymptotes. So x squared plus 3x minus 10. You're pros at factoring at this point, so you know what this should look like. I believe that's right. If someone watches this video and tells me that it's wrong and I have to redo it, I might cry. It's my second or third time making a video for this section because of changes that have come up. Let's see. Yes, that looks right. Let's look at the horizontal asymptote. That looks like it's going to be 0 because the numerator is smaller. Right. Let me scoot that over slightly so we can see the signs. Okay. And then last but not least, we have our y-intercept, which looks like a positive 3/10. So super, super small, just above the origin. Let's go ahead and plot everything. I'll go ahead and plot my 3/10. It's very small. And then we'll do our horizontal asymptote. So this is going to be a scenario where you're going to see that it crosses the horizontal axis, which is really annoying. We don't like that, right? The rule is generally that we don't touch those if they're an asymptote, but you're going to see an example where we break our own rule. So we'll do those. So that's going to be 2 and -5. Okay. Oh, and then let's do 3, 0. We'll call that a 3. Notice I'm not really labeling my points. It would probably be helpful if you labeled them. But I'm being lazy right now and I'm being a terrible example for you. But I think it's pretty clear that what points are, what the points are based on the color coding. So I think I'm okay for that today. All right. Now we run into a similar situation with this blue point. We cannot cross this axis. There are no points on that axis right now in this section, which means we run into the same problem where this curve has to touch that spot and go back up. That's all we really know for the middle. Okay, so I'll go ahead and draw that. Doesn't have to be perfect. That's good enough. Okay, and then the other thing that we really aren't 100% sure about, but could probably guess, is that this curve is going to come up and go straight that way, right? It's going to touch, cross, and then flatten out and never touch that axis again. Okay. If you are not quite sure, you can plug in a point here. So something, if you're unsure and you're like, well, what if it does this? You could plug in a point to confirm that it's actually the red one. So plug in x equals 3 and y is going to be positive, and that will tell you that that line is going to be above at that spot. Okay. So if you're not quite sure. The section on the far left, however, we do need to plug something in for sure. So let's say if x equals -6, what's going to happen? So we have -6 minus 3 over -6 squared plus 3 times -6 minus 10. So that's a negative. We will have 36 minus 18 minus 10. And that should be positive, which means we are going to be negative. Okay. So that tells me that my curve is down here. Again, that is all you're going to need. Nothing else is required for that. All right, on the last page, or second to last page, we are going to find functions of the graph. Starting point here is to write down everything that you know. I'm going to zoom in pretty far here so we can see everything. I have a vertical asymptote at x is -2, horizontal asymptote at y is 2. Oh, heads up, all of the numbers are 2s. So this one's kind of tricky, so I will again color code. The x-intercept is 2, 0. The y-intercept, shocker, 0, -2. All right, here's how I do this. And I don't know how other people teach it, but this is literally my approach every single time. At this point, we know that the denominator is where we find our vertical asymptote. So I'm going to write my vertical asymptote in factored form. That would get me -2 if I set it equal to 0 and solved. Then I know that my numerator gets me the x-intercept. So writing that in factored form gets me +2 when solving. Now, the next two parts go together. What I can do is similar to what we've done before, is set this equal to y and multiply by a. A is really your stretch factor, which is going to help us figure out what the equation should have for your horizontal asymptote and your y-intercept. We're going to use the y-intercept for x and y to find a. So actually, I'll erase this and do this part in red. So -2 equals a, right? X is 0, so it goes away. X is 0, so it goes away. And now we do the math. So we have -4 equals -2a, or a equals 2. A quick check will confirm that this is correct, and it will give you the horizontal asymptote as well as the y-intercept. The y-intercept for sure, because we use the y-intercept to find a, but it will also confirm that the horizontal asymptote is correct, right? It's 2x over x. So that's how you're going to find the equation of a graph. Let's do it again with this one. Looks slightly different, but that is okay. We have two vertical asymptotes. So we have x equals 4 and x equals -3. The horizontal asymptote is at 0. It's not like explicitly shown, but it is at 0. But you can tell by the curves on the edges. The x-intercept is at 3, 0. The y-intercept is at 0, 1. Let's do the same thing. I will go ahead and start with my vertical asymptote. I'm going to write it in factored form. You can also do that. I'm not too worried about it being in standard form. Factored form is way more useful anyway. My x-intercept will go in the numerator. And now we can set this equal to y with a, and we'll plug in that 1. So 1 equals a times -3 over -4 times 3. You can multiply everything onto the left to get -12, or you can simplify the right side first. So, right, the 3's would cancel and then the negatives would cancel, which is what I'm going to do. So I'm going to have 1 equals a over 4, and then a would equal 4. I think that's more efficient. You can do it however you want as long as you get a on its own. A quick check will confirm that that also gets us the horizontal asymptote that we want. Let's see. Lost my track of thought. -3 over x minus 4 times x plus 3. All right. Okay. All right, the next 3 were for you guys to do. So ideally, do those first before watching the lecture video. Um, I will give you a chance to pause now. Okay, hopefully you paused, and we'll go over these now. The spacing on these, I didn't do a very good job, so I do apologize for that. So for the x-intercepts, we have x plus 4 equals 0, or x equals -4. So we'll plot a point there. Actually, I think what I'm going to do is just do all the x-intercepts and then all the y-intercepts. For this one, we have x squared minus 4x equals 0. I can factor out an x, which means I have two x-intercepts, which is interesting. So I have 0 and 4. And here, I'm going to rewrite this as -4 over x squared minus 3x. There's no difference, but I prefer that. So there is no x-intercept, does not exist. So those are your three x-intercept, or those are your x-intercepts for the 3 of those. Let's look at the y-intercept. Y-intercept is going to be -2/3 here. It's going to be 0 here, which makes sense, right? Because this was a 0. And this one will also be none. Oops. Okay. So the reason this one is none, let me show you really quick, is if this is a 0 and this is a 0, you'd have -4 over 0. That cannot happen. So our y-intercept also does not exist. Okay. That makes this pretty tricky. pretty tricky. So we're probably gonna have to plug in some points to figure out what this is gonna look like. Okay, vertical asymptote. We can set the denominator equal to 0 and solve. Looks like it's gonna be at -3. So let's do a dashed line there. The next one is gonna be factored. So if we want to multiply to 6 and add to 1, that'll be -3 plus 2. So 3 and -2. So we'll do that. Based on my points, I feel pretty good about that. And then for this one, let me erase this so I can see what that says. X squared minus 3x equals 0. Factor out an x. So we have two asymptotes at 0 and at 3. So we'll plot those. Okay. All right, all of those are done. Now we are left with the horizontal asymptote. Let's do that in blue. Horizontal asymptote, let's look at this right here. That's going to be y equals x over -2x, right? Those powers match. So we're at -1/2, which might be a little tricky to draw. Let me do my best here. So it's about halfway. Okay. Let me move that so we have more room for the other one. This one looks like powers match. So let's simplify those coefficients. We're going to have y equals x squared over x squared, or y equals 1. So we'll plot that. And then here again, it looks like the numerator is smaller. So we're just going to have 0. We'll plot that. Get rid of this ruler. Okay. Now we have everything we possibly could. Oh, hold on a minute. I forgot to graph the y-intercepts. What was that? -2/3. So like there. And then, oops, yes. And then this one was 0, 0. We already did that. So we'll put that in red. And then this one had neither. Okay. All right, now we have to figure out, what does this look like? Okay. Um, I'll come over here and look at this and say, well, this looks like it will, let me switch over, go this way and then come down, right? There's nothing else that can happen on this side. Let me switch the laser. There's nothing else that can happen over here, right? We want this to pass the vertical line test because it's a function. So that is my only option. On the other side, we have something similar. We have another point. So I'm thinking it's going to look like this. And again, that's the only thing that can happen because we have to pass the vertical line test. You can't have another curve up here. So that's it for this one. Okay, for this middle one, something similar is going to happen to one of the examples from earlier, right? This has to come up and then come back down. It cannot cross this line. So I know for a fact that I'm going to come up, touch that point, and come back down. I also know that I'm going to have a curve that comes this way, and it's not going to touch that blue line, and it's going to go down forever. Now I just need to figure out what's happening over here. This is my only unknown area. So this, I already forgot what this was. This was -2. Find another color to do this in. We'll do green. So let's find what could happen over here. I'll plug in -3. Find some room up here. So we have -3 squared minus 4 times -3, and then -3 squared minus -3 minus 6. All right, so that's going to be a positive and a positive. That'll be 9 plus 3 minus 6. That's also positive. So that tells me the other curve will be right here. Now, for the last one, we're in kind of a pickle, right? There's no points to kind of guide where we're going to go. So at this point, we just have to plug points in for every section. So let's start with the left side. Highlight that in yellow for now. We can erase it later. Okay. Let's plug in -1. So if x is -1, we have -4 over -4 squared minus 3 times -4. So that's a negative, and then 16 plus 12. So that's positive. Oh, that's really good that it's going to be negative. So I don't have to move any of that work. Okay. Might be hard to see. So let me actually move it up here and resize. There we go. All right. So now we can do the middle. Let's do that in a different color. We'll do that in red. I'll go ahead and try 1. So if x equals 1, we have -4 over -1 squared minus 3 times -1. That's negative. And then that's going to be positive, positive. So we're going to have a negative here, which means I'm just going to have that U shape, very skinny in the bottom. Now, based on what the second one looks like, I would guess that the next curve is going to be up here. I don't know that for sure. I've done plenty of these, but I'm just not 100% confident. So I'm going to plug in another point just to confirm because I don't want to guess. I do want to make sure that I'm checking. So let's plug in 4. So if x equals 4, we have -4 over -4 squared minus 3 times -4. And that'll be a negative and a positive. So I was right. So that's going to be, oh, it's going to be negative. Interesting. Okay. That caught me by surprise. And that's a great example of why you shouldn't guess. All right. So that's what your 3 functions are going to look like. Let me zoom out here so you can see everything a little bit better. That should cover it for this section.